Hello friends, in this video we are going to see difference between the formula singly reinforced beam and doubly reinforced beam. So first step is finding design constant. Here Q formula is 0.5 into sigma CBC into N into J. So N formula is M into sigma CBC by M into sigma CBC plus sigma ST. M formula is 280 by 3 into sigma CBC. J formula is 1 minus N by 3. Same goes to doubly reinforced beam. Next step is calculating dimension. Dimension for singly reinforced beam. Span by 10 for calculating depth provided. Overall depth equal to depth provided plus clear cover 50. Next step, calculating effective span. It has two formula. Whichever is lesser, it is taken as effective span. Clear span plus depth provided or clear span plus support width. Next step is width of beam. If width of beam is not given in the question, this is the formula: overall depth by 2. For doubly reinforced beam, dimension is overall depth equal to span by 10, depth provided equal to overall depth minus clear cover. Effective span is clear span plus depth provided or clear span plus support width is overall depth by 2. So both are same for singly reinforced beam and doubly reinforced beam. Next step is calculating load. Dead load, live load. Live load is not given in the question, means we must assume it as 2 kilonewton per meter. Self weight is breadth into overall depth into 25. So same for doubly reinforced beam also. Next step is calculating bending moment and shear force. Here bending moment formula is WL square by 8. Shear force formula is WL by 2. Same goes for doubly reinforced beam, but we must find M1 and M2 formula also to calculate tension and compression reinforcement in doubly reinforced beam. So M1 formula is Q into breadth into depth provided. M2 formula is M minus M1. This is to calculate tension and compression reinforcement. So here it varies. Next step is calculating check for depth. Check for depth formula is M into QBD square. Same for doubly reinforced beam. Next step is calculating tension reinforcement for singly reinforced beam. Formula is M equal to AST into sigma ST into J into D. So AST, small AST formula is pi D square by 4. D is taken as 14 mm dia. And number of bars formula is AST by small AST. Next, for doubly reinforced beam, tension reinforcement is number of bars formula is AST1 plus AST2 by small AST. So small AST formula is pi D square by 4. D is taken as 18 mm. We assume it. Next, AST1 formula is M1 equal to AST1 into sigma ST into J into D. M2 equal to AST2 into sigma ST into D minus D dash. This is to calculate AST2. D dash is clear cover 50. Clear cover is taken as 50. So next formula is Here for doubly reinforced beam we must find compression reinforcement also. In singly it is not required. So formula of ASC is m into AST2 into D minus NC by 1.5 into m minus 1 into NC minus DC. DC is clear cover. Clear cover for beam is 50. NC formula is N into depth provided. So number of bars is equal to area of steel in compression reinforcement by small AAC. Small AAC formula is pi d square by 4. 18 is assumed as diameter. Next step is check for shear stress. Check for shear stress is used to find tau v and tau c values. Tau v formula is in IS 456 page number 83. Formula is shear force by breadth into depth provided. Tau c is calculated with the help of percentage. Percentage formula is 100 into AAC by breadth into depth. So tau c value is taken in IS 456 page number 84 table 23 referring to the percentage answer. If tau v is greater than tau c means here percentage value is taken in IS 456 page number 84 table 23 referring to the formula percentage 100 into AST by BD with the help of concrete given in the question. We take referring to this table tau c value. Next, if tau v is greater than tau c, in IS 456 they have given when tau v exceeds tau c, given in table 23, shear reinforcement shall be provided in any of the following forms. A. Vertical stirrups, B. Bent up bars along with stirrups, and C. Inclined stirrups. So we are providing vertical stirrups. So the formula for vertical stirrups is Vs equal to sigma SV into ASV into D into spacing. Vs formula is V minus tau c into breadth into depth. This is in IS 456 page number 85. This is same for doubly reinforced beam also. If tau v value exceeds tau c, we must find spacing. For shear stress, check for shear stress. This is the difference between singly and doubly reinforced beam. The main difference is finding tension and compression reinforcement for doubly reinforced beam. Here only the formula changes. We must find M1, M2 answer, and here compression reinforcement we must find ASC for calculating number of bars. This is the difference between singly and doubly reinforced beam. Thank you.